Hello everyone, I'm Xiao Gang. Okay, starting from this chapter, we'll begin writing some relatively basic cases. Then, for these cases, we might first go through the official ones. Also, there are some basic concepts we haven't finished explaining yet. For example, things like our logs or assertions, and also our strings. Let's take a look. The strings here seem... Yes, there are also some string processing. And these things, but we'll put these things in later chapters to explain. Let's start writing some of these simple cases first. Yes, because if we talk too much about technical concepts, everyone will find it quite boring. Let's first give everyone some cases to get their brains going. Now let's look at this simple programming introductory case. Then, let's first go over this concept document with everyone. Let's go through this document, then we'll do it for everyone. Then when we do it, we won't strictly follow this document. We will supplement it bit by bit. And we will also tell you here how he thinks, how the design was made, and whether it is necessary to do this in engineering practice. Oh, now there are some videos and documents here, and here an actor is mainly added. Then specify the static mesh component within this actor. Okay, we can take a look. Okay, there's no need for me to follow along and practice here, because some of the knowledge is already covered. You can open the document for this table yourself, then you can listen, or just listen to mine. Then we'll start first. At the very beginning, it needs to create a project and it needs some resources. Right, and we're using a C++ project, so how to create it? How to set up resources? We'll demonstrate later. You can do it when creating. Directly add our starter content. Of course, you can also add it later. Okay, we haven't added it yet. We'll guide you through adding it in a moment. And the way he creates this C++ class is a very standard way. It is created through the editor. After creating it, then he refreshes it at the specified location. And now he has a C++ class and then in his project, in terms of his module files, call this FloatingActor, that is a floating actor. And then this place, he explained this part, what it looks like. Then a pointer was added here. Note, this is a pointer, this pointer, it is a pointer. It is a pointer to a UObject type. Then this UObject type. It is called UStaticMeshComponent. It is not state mesh. It is a comtech. It is a component, and it can be created in Blueprint. But in Blueprint, do not mess up this pointer. That's the situation. Then here, in its constructor, it initializes this pointer, making it point to a newly created instance of ubuild and uses this pointer to point to it. And because UProperty protects it, meaning this pointer points to this OGB, this component, the ESRP, is also the stat mesh component. Note that I am referring to the same thing here, just that sometimes we call it differently. Then let it specify it, then attach it to this root node at the same time. Then here it loads static mesh. Note that this is static mesh. It is inside our blueprint. That blue static mesh, it refers to that. And here, it is loaded in this way. This is loaded via this path. This way of writing is not quite correct, but we will provide a standard way of writing for it. Then we will tell you what the correct way of writing looks like if here, the loading is successful. So here we go. Assign this static mesh to this static mesh component. And then, at this point, set its relative rotation to this. Here in the constructor, and this part is in tick. Tick is executed every frame. You know, when the game starts, we will execute gameplay, and then actually in tick. Here we first get our current position, and the current actor, which is essentially the root node's rotation. Then we calculate the current time, that is, how much time has passed since the game started. Then for this time, we will essentially perform a sine operation, and at the same time we take what it changes here is the height, and then make its height and rotation. Both follow this time, and perform an operation like a sine wave. Everyone knows about this sine wave, right? In mathematics, it's a sine wave like this. These two are essentially a time difference, and here we give an amplitude of 20. So it will essentially keep running a change. And then finally, we set this location and rotation. Or back. So it's equivalent to rotating when floating up and down. And at this point, our C++ code is written. And finally, after compiling successfully here, we开TE. This place still has the old interface. This is done by writing code and then hard recompiling. We don't want to do it that way. We can, after you compile successfully and launch it, we find its C++ class from here and then drag it into the scene. This is where it is directly dragged into the scene. And then here, we can see some of its details. This sets its position to directly above this table, right? And here its position is set. Then start running. Then click play. It will float up and down while slowly rotating after completing these simple operations. How do we expand on this? They expose two parameters. One is the rotation speed, and the other is the floating speed. So you can make some adjustments to them. Because previously it was at a fixed. So this is the speed. You notice it's edit anywhere. It's editable by default, and this instance is also editable. You can place two objects inside it so that their values are different. And note the property grouping. Here there will be a simple demonstration. Okay, you can also add some example components to make it float while rotating. So here it uses such a blueprint. This blueprint can select different meshes, and here is its example code. If you write it incorrectly, you can double check it. So this is the header file, right? And here it is a CPP file. As for this sample code, it is the sample code from the first volume. Okay, so it took about 5 or 6 minutes to go through this document with everyone. Then in the next lesson, we will implement it. This is our first and simplest basic case. Alright, we'll stop here for this lesson. Thank you everyone.